So far, we have looked at various measures of center and measures of spread. So today we're going to pick up with section 3-4 in your book, which is pages 13 and 14 in your note-taking guide. And we're going to look at one of many plots that we're going to explore in this unit. And this is a box plot, which is going to display some of these measures of center and some of the measures of spread that we've looked at thus far. So I'm picking up on page 13, and a box plot, which you will also see referred to as a box and whisker diagram. Alright, so the box being this rectangular piece right here, and you could think of these as whiskers perhaps. Alright, so this is a graph that consists of lines that extend from the minimum typical value in the data set to the maximum typical value. Alright, so here this whisker extends down here to the minimum, and I'm going to put in parentheses typical. So what I mean by typical is not an outlier or not an extreme value, all the way up here to the maximum typical value. So again, typical, I mean not an outlier, not an extreme value. So we have a minimum typical, maximum typical here, and then this box that we have shows three different values. It shows the first quartile, the third quartile, and the median, which your calculators will denote Q2, I think. Alright, so here I have my first quartile and my third quartile, denoted by these lines. Alright, and then here this is going to be my median, or my second quartile. Alright, so this would be the middle value, and then between this value Q1 and this value Q3, this is the middle 50%. Right? So just what we've looked at so far, we can see where the middle value might be, the middle 50% of values might be, and then the minimum typical and the maximum typical. Alright, and then lastly, any outliers would be denoted with an asterisk. So for example, in here my little generic picture, this asterisk would be an outlier. And then if you look at the bottom side, well, I don't have any outliers down here. So to determine whether or not we have an outlier, we have another rule. So you remember, thus far we've looked at the range rule of thumb, which we use to determine if we had an outlier. Well, here I'm going to call this the lower fence, and this one the upper fence. Alright, so these are not actually graphs. So this is not graphed. It's just kind of a rule to help you determine, well, if I have any data below this lower fence, that would be an outlier. Or if I had a datum above this upper fence, that might be an outlier. So I'm going to put in green here, not graphed. Alright, so this is just our rule, similar to the rule that we've already looked at for the range rule of thumb to determine if something's an outlier. So what we're going to do here to find this lower fence, I'm going to start at Q1, and I'm going to go down, denoted by subtracting 1.5 times the interquartile range. So I would start here, and I'm going to go down 1.5 times this interquartile range. So if you remember, our interquartile range is the range between Q1 and Q3. Alright, and then similarly our upper fence, we're going to start at Q3 now. Alright, and I'm going to go up, denoted by adding 1.5 times the interquartile range. Okay, so I would start here and then go up 1.5 times the interquartile range, and if I had a datum larger than this, I would denote it with an asterisk. That would be our rule for determining whether we have an outlier. Let's look at example 1. So this example is on page 13, but the data which I have at the bottom here is going to be on page 14. So we want to construct a box plot for the data on the following page for the total number of medals won by the top 30 countries in the 2012 Olympics. So down here you'll see listed various countries and how many medals they won. All right, so the first thing we might start with is the median. Now, if we're going to do this by hand first, but if you remember to find the median, well, I could find where my middle value is. But I'm going to do a little shortcut here because I know I have 30 countries. So because this is an even number of data, I know that my median is going to be halfway between the middle two. All right, so halfway between 15 and 16. So I'm going to count down here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and this is 16. So my median is going to fall right here between these two. All right, so if we wanted to know what's halfway between 17 and 17, well, that's just going to be 17. All right, so I'm going to come down here to 17, which I think might fall about right here, and this is going to be my median. All right, so next I want to find Q1 and Q3. All right, so next I'm going to find Q3, or the third quartile. So I'm going to take the top half of my data, which would be United States through Spain. All right, now let me block these off. I'm going to go from United States here to Spain. All right, and I want to find the median of the top half of my data. Well, I know I have 15 data, so the middle data would be number 8. Or if you wanted to just use the process of elimination, you might say, all right, I'm going to go through these two, these two, these two, and just count in until you get to the middle datum, which is 34. So this is going to be Q3. All right, so I'm going to draw a line here at 34. All right, and I can do the same thing for the top half of my data. Let's change colors here. So now I want to look from Brazil to Colombia and find the middle data. So we could do it like we did before, you know, count off from the top to the bottom, or if I know there's 15 data, the middle datum would be 8 in. So I'm going to count in 1, 2, 3, 4, 5, 6, 7, 8. So here I have that Kenya would be Q1. So 11 would be right here. So now I can draw my box. Alright, so next I need to use my rule to determine whether there are any outliers to see where my fence might fall. So I'm going to start at Q3, and I'm going to go up 1.5 times the interquartile range. Alright, so Q3 we have determined is 34 plus 1.5 times. Now let's see what my interquartile range would be. That would be the range between 34 and 11. So 34 minus 11 is going to give me 23. All right, so 34 plus 1.5 times 23 would give me 68.5. Okay, so any value larger than 68.5 would be considered an outlier. So let's look here. Do I have any value? Yep, United States. I would consider this guy an outlier. China is an outlier. And Russia here are going to be outliers. Then 65 is below that. So this maximum typical value is going to extend up here to 65. All right, and now I can denote these three countries with asterisks because they are outliers. Okay, so similarly, we can determine our minimum typical value with our rule here. If I'm going to start at Q1 and I'm going to go down 1.5 times the inner quartile range. All right, so Q1 is 11 minus 1.5 times 23. All right, so 11 minus 1.5 times 23 is going to give me negative 23.5. So I look down here, did anyone get fewer than negative 23 metals? Well, that doesn't even make sense. Our minimum value is 8, which is clearly above negative 23.5, so I have no lower outliers. So here I'm going to extend from 11 down to my minimum typical value, which is 8. So now I'd like to show you how we might find this graph in the calculator. All right, so here I'm going to go to my statistics menu, which is number 2. So again, I can either move the cursor to the statistics menu and hit execute, or my other option would be if I'm on the statistics menu, I can just choose the number 2. All right, so in list 1, I want to enter these data. So I'm going to again look on page 14 and enter the data. 104, execute. 88, execute. So right now I want you to pause the video and enter the data on page 14. So I now have my data entered into list 1. So here, if you hit exit a couple times, we go back to our main menu for the statistics menu, and if you do not see graph, calc, tests, and so forth down here, you might need to hit F6 a couple times to cycle back through your options until you see graph, calc, and so forth. So what we would like to do is graph these data, so I'm going to choose F1. Right? So here we have graph 1, graph 2, graph 3, so these are various graphs we might explore. But before we get that far, we need to set up our graph. So I'm going to choose F6. Right? So we're given a number of options. First, it says, which of these graphs would you like to set up? Step graph 1, 2, or 3. So if I hit exit back, I'm saying, which of these 3 would you like to set up? So I'm going to set up, well, we'll go with graph 1. So I'm going to choose my down arrow here, and what type of graph do I want? Well, here are my options: scatter, XY line, and so forth. Well, I don't want any of these, so I'm going to choose F6 for more options. And now I see under F2 a median box plot. So I'm going to choose this. Now you see when I changed the type, my options down here also changed. So where are my data? That means the X list. That's where I stored my data. Well, I put them in list 1, so that's fine. The frequency, each of these data occurred once. Now this is important where it says outliers off. I'm going to choose on. So if I didn't change that to on, then it wouldn't give me those asterisks we talked about, or it wouldn't use that rule to determine if I had outliers. And these other options you can play with, but for our purpose, they're fine as is, whether the color of the box and the whisker and so forth. All right, so now that I have this set up, I'm going to hit exit. So I just set up graph 1, if you remember. So if I choose graph 1, I now see my plot. All right. So here we have the plot that we just constructed by hand. If you wanted to know what these data are, see here it might be hard to guess. So I want to trace. So do you see trace is written above F1 here in yellow? So if I want something in yellow, I'm going to first hit Shift and then choose trace. So it's telling me my minimum typical value here is 8, and I can use the arrow to move to Q1, which is 11. Move over again, the median is 17, Q3 is 34, the maximum typical value is 65, and then here my outliers are identified as 82, 88, and 104. So hopefully this looks similar to the graph that we just constructed by hand. Alright, so let's look at another example here. So these data were taken last fall from the cross-country teams here at SMC. Here I have separated these data into two groups. I have my sophomores here, their times, I think this was for an 8K, and then my freshmen. So I want to use the calculator to graph both of these data sets at the same time. So if I come back to my calculator, I am going to hit exit a couple times to get back here, and I want to put my sophomores in list 1, and here I'll put my freshmen in list 2. Well, I want to get rid of these data. I could hit delete a number of times, but a quicker way to do that, if I hit F6 for more options, I can delete all, which is under F4. So that cleared my list. So here I'm going to enter my sophomores in list 1 and then my freshmen in list 2. So I might start with Austin 26.0, execute, and so forth. So right now I want you to pause the video and enter your sophomores in list 1 and your freshmen in list 2. So I now have my sophomores in list 1 and my freshmen in list 2. I'm going to choose set. If you don't see this menu from before, let's hit exit a couple times, and I'm going to go to the graph menu. Alright, so let's set up, well, this is still set from our last time. Graph number 1 is a median box. We're going to look in list 1, that's where our sophomores are, and we have our outliers on. So if I exit back and choose graph 1, I get a graph that looks something like this. Alright, now here we can find our median, our Q1, Q3, and our maximum typical. Now here I notice that I don't see a bottom whisker. So that might be peculiar to you, but if we look at our data, we might be able to explain that. So here I have 6 data, so my median would fall between these two. My median. Alright, so then I look at the bottom half of my data and find the median. Well, this is going to be Q1. Alright, then if you look here, my minimum typical value would be 26, but you see that's the same as Q1. So that's why you might not see that bottom whisker. So I'm going to exit back. Now I want to set up graph number 2 to look at my freshmen. So again, I'm going to hit F6 to set. Now I want to set up a separate graph to look at the freshmen. So I'm going to set up graph number 2. Alright, so if I come down here to the type, I want a median box, which I don't see that listed, so I'm going to choose F6 for more options, and then there it is under F2. Now where it says XList, that's where I stored my freshman data. Now if you remember, we put the freshmen in that second list, so I want to change this to list 2. So I'm going to choose F1, and then type 2. Alright, so the frequency each occurs once, and I want to turn my outliers on so that if there was an outlier, it would be identified. So now that I have this set up, I can exit back and choose F2 to look at my freshman data. So we see they are graphed here. Again, if you wanted to pull these values, you could select Shift F1 for trace, and we see our minimum, or our fastest freshman, is 26.6. We have Q1, our median, Q3, and our maximum. All right, but what we would like to do, we would like to compare the freshmen and sophomores. So if I wanted to view both of these graphs, graph 1 and graph 2 at the same time, I'm going to go here to F4 on my graph menu and choose Select. So here I want to view graph 1, which is my sophomore, so I'm going to turn that one on, and graph 2, which is my freshman. I want to view both of these, and graph 3 we're not interested with right now. So I'm going to set that, turn those two on, and choose F6. So here we see that we have both the sophomores and the freshmen on the same graph. So again, if you wanted to pull these values, I could hit Shift Trace, and I see that my fastest runner is a sophomore at 26 minutes. Then I have another sophomore at 26 minutes. I can use my down arrow here to jump to my freshman, and then I had a freshman at 26.6 minutes, and so forth. So that's how we would graph both the sophomores and the freshmen simultaneously.